So this one's design language. I think this is one of the things that I noticed immediately is somewhat lacking here. And I think that's also one of the things that's been creating a little bit of difficulty in just getting the ball rolling in a lot of our projects that have to do with design. Can you guys hear me okay? Okay. Okay. So just real quick, I won't spend too much time on this slide. Essentially, design language is just the way brands communicate that a product is theirs through whatever product design identity or brand language they decide to use. So that does also include physical and digital mediums. That's really important to know because even for you people who aren't mechanical focused and want to do things and have a language that you speak when you do your software development and maybe like UI and GUIs, Apple's a really good example of this, right? So you know it's an Apple phone if you don't see the rest of the phone, but you see the page itself, because that the way they design their icons is part of their design language. The design language is everything, and you can read a few articles about design language on how people, if you grow up to be an engineer, you can be resistant of it because you're trained to do something in a technical way, not necessarily an artistic way that speaks to a larger audience. So brand language is something that as engineers grow up, you need to get more familiar with it and you need to be more accepting that this is a thing that companies do. And why it's important, like I said, like companies, you can tell that if I covered the little BMW logo, you can tell that that's a BMW car, right? Because their design language tells you that with the way they do specific contours. And it's not just with specific companies, it's with ecosystems of products as well. You guys remember the generation of phones that all had basically the same exact phone with a little square camera bump now that right before everyone started doing their own unique thing? So it's shared within ecosystems, and that's really going to be important to think about when we think further into what Robocop robots look like that we're competing against, right? So brand language and design language does not just come into professional products, it comes into everything we do, including the specific robotic ecosystems that we're a part of. And we want to be able to emulate that kind of stuff. So how it's determined is essentially between the strengths of the people and the equipment and the resources you have. So I want you guys to think really hard during this presentation, after this presentation, on what we think our strengths are as people and what we think our strengths are within our shop as equipment and things like that. And I'll go through that here in a bit, but I said this already a little bit. How does this help us specifically? Design language allows and gives a set of standardization that takes the guesswork out of the first few stages of the engineering design process, right? So when you're doing your initial ideation of something, but you don't have a backbone of what that something is supposed to look like in the first place, it becomes really hard to get that ball rolling, and that's how projects get delayed and canceled. So if you have a design language that you can stick to, you can at least get through those first 3 or 4 phases of the design process and get products out that much quicker. Obviously, that then leads to a lot of these other things to help build institutional knowledge. So the fact that you guys end up teaching the younger students, if you can develop and build a design process that you can then translate to the younger students after you, that consistent design process is going to help us keep a consistent transfer of knowledge generations to come. And you can come back years later. This is going to happen every 10 minutes, isn't it? That's going to come back years later. All right, guys, if you do that one more time, I'm done. That's going to help years later down the road. You can come back in 10 years and still see your fingerprints in the way we design things here. So after that, I don't know how to fix this, so we'll just have to keep doing this. No, so my motto to every team I've ever worked with is steal from the best, invent the rest. Teddy.
So what like something like a BSM and what
Yeah. Well, okay, so that's brand identity, not necessarily design language, but that is part of it. So you can incorporate specific iconography into things that you design to give you the power to do that. So yes, somewhat. Yeah. So I'm glad you asked that. So design language does cover both color scheme and type of fabrication. So for Ecolab, the last place I work, I designed soap dispensers and other things out of injection molded plastics because that was, first and foremost, our design language was injection molded plastic. The second thing was the color scheme. So base white, accent gray, iconography blue, right? everything we did was in that pattern, and you can see that in the identity of everything we do, even in the couple of molded parts I have at my desk from Ecolab, same iconography. Regardless of shape, it'll always have large rounded contour, a chamfer on top and bottom, chamfer on top and bottom, with a little bit of an accent chamfer as well to help transition the curve. So every product from a bug light, this is a fly light that captures bugs. This is a soap dispenser. These are solids dispensers for like dish machines. They all basically look the same, but are their own unique thing. And that's what I want you guys to be able to identify when you're designing stuff here is you can design your own thing, but still have an identity within the brand of whatever BSM engineering robotics is. So I think some of the things that help here is we are very standardized. We standardize in the fittings we use, we standardize in the tools that we have, and we're equipped with the equipment in our shops to be able to consistently hold that standard. Even after I leave, right? I left Ecolab, they can still design things that look very similar to what I designed in the past. So having the equipment and standardization is really helpful for companies, and it's going to be really helpful for us too. And I don't think we're there yet. So I want to really, especially the E4 kids this year, I want to work with you guys to figure out what this standardization should look like that'll pass generations to come. And that includes things as simple as we will always use 1032 bolts. We will always use 3/16 rivets, which is kind of what a lot of FRC teams use. This is a competitive background that I come from. I've done this for 20 years. You can look at robots. This is 2014, 2019, 2018, and they all look the same. And this team wins constantly because they don't have to start from the very beginning every time. They know what they design with and they know what they design for. So they can skip those steps of, I don't know what material to use. They always use the same exact type of material and they just make it so they can accomplish a specific game. They're the most winning team in FRC history. Same with this team down here. These guys are kind of a special case because they're sponsored by NASA. NASA engineers help them build the robots, so don't take that too seriously. But still, iconography, brand language, design language within a robotics ecosystem. This is something I built out for my team. This is what we use. We use polycarbonate, churros, and aluminum box tubing, 2x1 or 1x1. For all the structure, we use 1032 and 3/16 rivets for all the fasteners, and then we use things like polycarbonate and aluminum plate, 090 or 1/8 inch for all the supporting structures. And that's it. And I tell them that's exactly what you're going to use, and that gives them that fills in the gap of I have this idea in my brain, but I don't know how to make it designed. We can design around the components that we know we'll use. Same thing for Robocop. Like I said, there is ecosystems build a certain type of consistency in their design language, even though they all come from different teams. There's a lot of similarities here, right? I'm being intentionally flippant about how alike I chose the pictures to be. There are definitely other robots I could have chosen, like ours, but you see the successful robots and you see the type of design language they use, and because they do that because it works. And like I said, my motto has always been steal from the best, invent the rest. We don't have to, I say that we don't have to recreate the wheel, but we are literally recreating a wheel, but that's for a different reason. I think that is a really cool idea that we could do well with. But yeah, things like that. We don't have to start from scratch every single time we do something. We can take inspiration from things that exist and work off of it. We don't have to pretend we live in our own little bubble that doesn't have any prior knowledge or prior institutional backing to go off of. So talking from prototyping to manufacturing, these are the three primary things that we'll do, right? We'll make flat parts, we'll make structural parts with basically straight cuts or simple cuts, and we'll make specialized parts. And the way you transition that between identifying the difference between a prototyping phase of doing something and the final manufacturing phase of doing something is the tool you use. So when we use the laser cutter, we're using softer materials, wood and acrylic, to make prototype parts. But we can make those same exact parts out of metal using the mill. So don't ever feel like you have to fully rely on acrylic parts or wooden parts as a final part on a robot, because we've got the capability to make that same exact thing in metal or in polycarbonate that is going to be much stronger and able to withstand a lot of the challenges that we're going to do. Same thing for structural parts. Right now we only have a bandsaw, but a bandsaw can do a lot when it comes to cutting parts at either a simple angle or a straight line, right? So using 80/20, and 80/20 kind of exists in both places because 80/20 is good at quick manipulation of sizing. And we could also use wood, and then that wood transitions into box tubing over here. And That's going to help us understand how to transition from prototyping things really fast to final version of manufacturing that has really cool design language of what we want it to look like. And in specialized parts, this is the biggest thing. When things are a little bit more complicated and not just simple flat parts or structural single cutoffs, I want to make sure you guys are designing it in a way that one is, yes, it's possible to 3D print, but two is also possible to make on an actual legitimate manufacturing equipment like a mill, right? Most companies, and 3D printers just aren't here yet, most companies are not gonna give you a product that they want you to make that can't be made on a mill. So if you design it only for 3D printing and it's not feasible to make on a mill, you guys might not understand the difference there yet, but I can help you understand that if you want. Then they're gonna reject your part every single day of the week. Yeah.
So what do we do that for the tires as well? What do we do?
Well, for the tires, just for the casting shape, I think since we had the big stacker working, we can actually get that to be the cast state shape, and then we can use silicon, two-part silicon to create our mold. All right, so this is kind of my last slide. Where does this leave us? I think the next thing we need to do is we need to figure out what we want to design standardize around and move forward from there. And really stick to the fact that we're only using these certain things for the prototyping type of situations, and then using these specific things for the manufacturing final robot design type of situations. I don't necessarily want to see wood ever on a robot, but there are applications where wood is still appropriate in a final fabrication form. So these are a couple of questions I want you guys to think about before we move forward. I guess before we meet again in E4, as we continue to talk, is what are the core materials we want to build a design language around? What is just the visual aesthetic we want to build a design language around? And what materials have we seen from other teams that we can just apply today, right? Like, it's not that hard. As complicated as these are, that's a flat plate connected by a shaft. That's a flat plate probably connected by a cross beam and some rivets, right? That's a flat plate that just has really fancy pocketing. You can look at these things and assume that they're really, really difficult to do and just completely take it out of your mind. Or you can dull it down to the most basic form of what these things are and really understand how these things are made. Like, this is a complex looking robot. That's a flat plate with cross beams. We can do that. We've done that. We've done that 100 times. So we just need to be able to take complicated looking things, boil it down to their base components, and understand how we want to use those base components in our own form factor. Any questions? So next week, I want you guys, yeah, Owen. I want to give you a baseline of what I've used in the past, and then I want to get your guys' feedback on what we think might be more appropriate if something isn't appropriate for us or we don't have the equipment to use it.
And so for the standards that we already have in Workbench Chapter 1, are they going to have to remake most of that?
So I think Chassis 1 has a really good example of the standards that we want to have for prototyping purposes, right? So I think we can keep those things. No offense. No offense. You're building off of what you had. But yeah, it's like we'll build off of that and understand how to transition that from looking like a prototype robot to let's figure out the brand language and use that as our core example of how to turn that into from a prototype looking robot to a professional looking robot. And I'll work with all of you to make sure that happens. Cool. Next week, I really want you guys to come back with some ideas for what our team standards are. So that's going to be next week's conversation is our team design standards. Thanks, everyone.
Thank you. Thank you.